Today we're going to be going over a practice lesson on the properties of matter concerning the pure substances, homogeneous mixtures, and heterogeneous mixtures. This is focused on TEAC 6.6b for 6th grade science, and this would be considered day 2 of the matter and energy unit. To start, after our students arrive to class and sit down, we would be pulling up our video, which is just a quick video that shows the pure substance or mixture video.
When we look at the different particles of matter,
And it goes through that video. I'm not going to play it just because it is someone else's video and I don't want to repost it for this channel at the moment. So we go through this video and then we come to opening our review vocabulary. So on our previous day, we would have discussed what an element was and what a compound is, and we would have questions for the class. I believe that having the definition on the screen as a review isn't a bad thing. So we asked the class what their examples would be. So we ask, what is an element? And they can tell us oxygen or iron or magnesium or anything else we might have gone over in the previous day, and have them possibly pull out their periodic tables or have a large periodic table on the wall so that way they can point to it. Then we would go to compounds and we would ask the same thing, just, what are some examples of a compound? And with that, we would talk about water or hydrogen peroxide or other compounds that aren't just mixtures. And then we'd go back to our video to discuss what we had learned. So we'd go back to our video notes and look at homogeneous and heterogeneous mixtures and go over the differences. So first, having everybody write down in our lab journals our definition, homogeneous mixtures, and go over a type of mixture where different substances are blended so evenly that they look like one single consistent substance. And with that, we would talk about something like salt water and sugar water, or brass and brass or steel, where they have been bound together to look like one fluid material. And then we talk about heterogeneous mixtures, a type of mixture where different substances are not evenly blended and are visibly distinct. And with that, we want to talk about like oil on water, or trail mix, or concrete, where you can see the different minerals in it. But we'd follow that up with our lab. And I think that a really strong way to teach students is by having hands-on teaching. I don't want kids sitting down for too long. I want them kind of up, moving, and talking with each other so they can get their ideas out instead of just sitting there and having me lecture at them for an entire class period. So I would break our labs down into stations. The way I would ideally have it is that we, at the beginning of the year, have established 3 different station groups. So our class would be broken into 3 groups. Or I would double that and make it 6 and have 2 groups at one station. And this is solely time dependent. I'm not sure how long these labs would take each or how long I have in the classroom in this hypothetical. So we can add labs, we can take labs down, but station 1, we'd want to break it down. And of course, I don't have a photo of the lab because I came up with it and I haven't done it myself since writing up the lab. But the photo of a previous lab, or whenever I get around to getting to test it myself, would go into that slot. And all 3 of our stations have those blank slots set up for that reason. In this one, I took inspiration from a video I saw that broke down a cup that was filled with iron filings, salt, and sand, and how we break that down. So the first thing we want to do is give the students this cup of mixture. And in their lab journals, I want them to write down whether it is going to be a homogeneous mixture, a heterogeneous mixture, or is it a pure substance. And hopefully, with what we had talked about, they would know that it is a heterogeneous mixture. And if they need some explaining as to why that is, I would like for lab groups to be able to work together and explain it. But if they need that help, that's what I'm there for. So when we mix them together, they are not evenly distributed. They are not evenly blended. They are a kind of a Mod Podge. You can see the different parts. You can see it's not completely blended. You can see it's not melded together very well. And one of the ways we can show that it is a heterogeneous mixture is that we can break it down really easily. So the lab for this is, I want you to break this apart. I want you to put it into separate things. I want the iron filings on one plate, the sand on one plate, and the salt in its own section. And I don't say plate for that because there is a method to this madness. So I have written down in the notes for this PowerPoint, which I will be turning in. In this lab, students will be given a cup of mixed materials, a laminated instruction sheet, and the tools to break down the substances into its different parts. Students will be given a cup of mixed salt, sand, and iron filings, and will be asked what type of mixture they have, a homogeneous, heterogeneous, or pure substance. Students will then be instructed to take out different parts of the mixture to show that it is a heterogeneous mixture. A laminated instruction sheet will be given to the students. I feel like problem solving in this situation is something I want to promote, and not necessarily just for students who are kind of showing greater understanding, but I do want to encourage problem solving in this as just a general tool. So the instruction sheet will be there, but it is encouraged that they are able to kind of start piecing it together without the instruction sheet. The tools provided will be a magnet, another cup, water, a coffee filter, a pipette, or a stirring stick, and 2 paper plates. The instructions for this go step by step. Step 1, students will use the magnet to take the iron filings out of the mixture and place them onto the paper plate. Step 2, students will pour the water into the cup Step 2, students will pour the water into the cup with the mixture and stir the mixture to dissolve the salt into the water. And I think this is the step where students might be a little confused because that might not be the first thing they think of, but that is okay because, again, that is what we are there for, to kind of guide and instruct. Step 3, the students pour the salt water and the sand mixture through the coffee filter into another cup, separating the salt and the sand. At the end of it, there are some questions they'll have to answer in their lab journal. So I want them to explain what a homogeneous mixture is, what a heterogeneous mixture is, and what a pure substance is. And they can use the examples in front of them. I want them to explain how they remove the iron filings, how they remove the sand, and how they remove the salt. And then the final question is the leftover salt water a homogeneous mixture, a heterogeneous mixture, or a pure substance, which in this case, it is a homogeneous mixture, as long as it has been broken down fully. Lab number 2, or station number 2, we call Eat the Answer. In this lab, students will be provided with sugar, water, preferably bottled water, and packaged pretzels, M&Ms, small cups, and plastic bags, as well as 3 paper plates will be set in front of them to show their results. In this lab, students will be instructed to provide examples of a pure substance, a homogeneous mixture, and a heterogeneous mixture. For students that might need help for this, there will be tips on the bottom of each plate for which substance the students are having trouble with. The pure substance plate is expected to be a bag of sugar or a cup of water. The homogeneous mixture should be a bottle or cup of sugar water. And the heterogeneous mixture kind of comes down to just being a mix of whatever the students want to put on the plate. It can be just the pretzels and the M&Ms. It could be the pretzels in the water with the M&Ms. It could be the pretzels in sugar water with M&Ms. As long as they understand that the different mixing and the different blending does make it a heterogeneous instead of a homogeneous mixture. At the end, they will be prompted to fill out their questions in the lab journal. Once again asking, what did you choose for the pure substance and why? What did you make into a homogeneous mixture and why? And what could you mix into a heterogeneous mixture and why? At the end of this lab session, we'll pass out fun-sized bags of M&Ms, pretzels, or other allergy-friendly snacks, so that way students don't have to try and eat wet pretzels. For station number 3, we're calling this Pure Potions. And this is something I'm kind of trying to brainstorm a little bit more. I have the concept, but I don't necessarily have the theme for this station. In this lab, students want to find the potion mixture that is a pure substance. In this case, they're looking for pure sugar. 4 test tubes will be filled with sugar and a mystery substance, baking soda or crushed Alka-Seltzer, and 1 with pure sugar. And there's a caveat to that, but we will discuss that in a moment. Students must figure out which substance is pure. They will receive a paper at this station that grants them the information that they will use the solution, which will be vinegar, in the beaker to find out which is pure sugar. They will know that the pure sugar has been mixed in with other substances, and that when the solution is placed on the impure substances, it will bubble. Students will be instructed to pour out some of the mixture onto the different plates that they have. During the instructions in this lab, make sure it's clear that students are not pouring into the test tubes unless you are prepared enough for 3 different rotations. Students will sprinkle out the mixture onto the plate and use a pipette to drop the solution onto it. If it bubbles, they can tell that it isn't pure, and students should report their findings into the lab journal. Now, I reference another YouTube video here in the notes, just giving a bit more of a farther thinking idea. I had considered, what if 3 of them will bubble and 2 of them will not? But at this point, they know only 1 of them is going to be the pure substance, so they receive a second paper. Have 2 test tubes that will not react to the solution, 1 with pure sugar and 1 with salt and sugar. Once the students realize that there are 2 test tubes that are not bubbling, they have to find out which one is pure sugar. Bring in the second solution, which will be alcohol, and 2 test tubes, with a new note that says only pure sugar will dissolve in this solution. Have students spoon out some of each mixture into the new test tubes and then pour in the solution. Have them cover and shake the solution until the sugar has dissolved, allowing them to see which is the answer. At the very end, allow the students to use a water-dampened tongue depressor to taste and see if they were right by scooping a small amount onto the dispenser and tasting the pure ingredients. This last is just a bit of fun, so that way they can pour a little bit of the salt sugar or the pure sugar onto a tongue depressor so they can taste if it's pure sugar or if it's sugar and salt and see if they got it right. That would be our entire class for that day. At the very end, while we're packing or while we're collecting our things, we will ask the end of class thought question. I would like just something they can think about and bring back the following day. What other pure substances, homogeneous mixtures, and heterogeneous mixtures can you think of? And I want each student to write down and bring 1 example of each to the following class. That is the end of our lesson. That is all we have and all we have prepared. But I believe that that would make for a solid, full class that could keep students engaged and keep them excited about learning the different properties of matter.